Hi class, in this video we're reviewing for our quiz on circles. The first question says how many chords are in the diagram. So we have 1, 2, 3, and 4 chords. The chord has to go completely across the circle. So we have 4 chords. The second question says what's the longest of those chords? So the longest chord has to be the diameter, which is AC. The third question says, how many tangents do we have? So we have 1 tangent right there. In the second problem, if we mark up the diagram, it says that the larger circle has a radius of 10, and the smaller circle has a radius of 7. And we're looking for some missing dimensions here. So if 10 goes from B to D, and 7 goes from E to C, then we could see that that overlap right there is 3. So the distance between C and D is 3. And then if the distance between C and D is 3, then the other missing dimension must be 7 here, so that the 7 and 3 add up to 10. And then on the other side, if C to D is 3, then D to E has to be 4, so that that whole distance is 7. Okay, so now looking to answer the questions. What's the distance from D to E? So we figured that out. That's a distance of 4. The distance from A to F, so if we add up the distances across the segment A to F, we have 31. And then the perimeter of triangle BGE. So we're going from B to G to E and adding up those distances. Okay, so the key is that this radius here is 10 and the radius here is 7. So adding up the distances from B to G to E, we have 31. Notice that's the same as the distance from A to 7, or from A to F, because this radius here is just swinging up to create a triangle. The radii on both sides are swinging up to create the triangle. Then the distance from A to E, so distance from A to E, we could add up those distances and we see that it's 24. And the perimeter of quadrilateral BHEG, so we could fill in that this radius is 10 and this is 7. So if we add up that quadrilateral, we'll have 34. Next question, we're determining these arc measures. So marking up the diagram, we have the arc from C to D is, so this arc here is 76. Okay. And since we're only missing one arc from A to E, it's 360 minus that list. So then the arc from A to E has to be 78. Okay, so now that all of those are filled out, we're looking from the arc from A to E, so that's 78. Then from A to B to D, so A to B to D, if we add up that list, we get 206. The arc from D to A, so D to A, if we add up that list, we get 154. And from B to C to E, so we're going from B to C to E, so adding up those angles, we'll get 255 degrees. In this problem, again, it's worth it to first mark up the diagram. So since we have this diameter right there, that adds up to 180, we have the 108, so the other section's 72. We could mark that as the same as B to C. And then we have the diameter going the other way, so 180 minus 72 is 108. Divided by 2 is 54. So each of these sections is 54. So now that the diagram's marked up, we're looking from A to C. So A to C is 126. From D to A to E, so D to A to E, if we add up that list, is 252. From E to C, so that's the short distance from E to C right there. 108 plus 54 is 162. And C to D, that short distance, is 54. In this first problem here, we're looking for distance from A to B. So if we mark up the diagram, we have a radius here of 5, so that whole side is 13. So we have a right triangle with sides 5 and 13, so the missing one is 12. It's a 5, 12, 13 triangle. We could get that with Pythagorean theorem. Marking up this diagram, we have the right angle right there. It's a 30, 60, 90 triangle. Looks like we have the medium side, so medium to short is going to be 6. And then short to long is 12. So that whole hypotenuse is 12, but the radius is 6. So the missing section from D to A is 6. In this problem, we're looking for the distance from A to B, marking up the diagram. The radius is 3, the hypotenuse is 9. So doing Pythagorean theorem, 3 squared plus x squared is 9 squared. 81 is 9 plus x squared. So therefore, x squared is equal to 72. Square root both sides, and x is 8.49 approximately. So that's our distance. This last problem, we have a right triangle because of the tangent. So we have a 3, 4, 5 triangle. That hypotenuse is 5. The radius is 4. So the distance from D to A is 1. 5 minus 4 is 1. In this problem, we're looking for the distance from B to C. Okay, so marking up the diagram, we have A to B is 8. So the corner theorem, we have that other section is 8. A to E is 20, which means the missing section is 12, because 8 plus 12 is 20. So the other section of the corner is also 12. C to E is 18, meaning that these missing sides there are 6. So B to C has got to be 6. In this problem, marking up our diagram, we have A to C is 24, and A to F is 10. Okay, so that means that A to B is 10, that B to C is 14. This other section is 14. The other piece of information we have is the perimeter is 60. We're looking for F to E, which is the same as D to E. So if we add up all these sides, if we add up all these numbers around there, and we'll get 34 plus 14 is 48. So 48 plus 2 of the x's adds up to a whole perimeter of 60. That means that 2 of the x's is the same as 12, and x is 6. So solving that linear equation, then these missing sections must be 6. Now we'll have a perimeter of 60. Going through this problem, it looks like we have all of the arcs except for one, so 360 minus that list of numbers. So our last arc must be 48. So that x is 48. We see that that matches with this one, which means that that 9 has also got to be that 9. So y is 9. In this problem, finding the missing arc to add up to 360, then that's 110. So that 110 and that 110 says that y has to be 21. So y is 21 centimeters and x is 110 degrees. In this problem, marking up our diagram, it looks like we have a 3, 4, 5 right triangle right there. So By the symmetry, we'll also have a 4 here. We know that the perpendicular radius bisects the chord, so both sections are 4, and A to B has to be 8. In this problem, if we swing down that radius, so there's 41, and it's the perpendicular radius cuts the chord in half, so that's both 9. So we have a Pythagorean theorem of 9 squared plus x squared is 41 squared. So when you solve out that problem, x squared equals 1600 and x is 40. So x is 40. In this problem, we're looking for the missing arc x, but we know that all of these are the same because the chords are the same. So 360, take away the 138 is 222. And if we divide that into 3 equal sections, then each section has to be 74 degrees. In this problem, by the symmetry, we know that the whole chord has to be equal, has to be 36. Oops, 36. So since that's cut into half, then each section has to be 18. So x is 18. In this problem, we know that this red chord right here is congruent to the blue chord right there because there's a 1 and a 2 section, a 1 and a 2 section. Okay, so what that means is that this 145 degrees from here to here has to be the same as 145 degrees from here to here. So that missing section of x has to also be the 85. That's the key. Right, so if that's 85 and the whole thing adds up to 360, then the missing arc measurement has to be 130. Now the whole thing will add up to 360. In this problem, it looks like we're actually only looking for the x. So finding that x, what we could do is swing the radius this way to see 15. And then we could do Pythagorean theorem. So 12 squared plus x squared is 15 squared. When you solve out that problem, you'll get that x is 9 because it's a 3, 4, 5 right triangle multiplied by 3. So 9, 12, 15 right triangle. In this problem here, we have an arc which collapses to angle 1. So since that arc is 180 degrees, then angle 1 has to be 180 divided by 2, so that's 90. So there's our 90. And if you have a 90 and 21, the triangle has to add up to 180, so the missing one has to be 69. Now the triangle adds up to 180. The next problem, it looks like that 31 traces out to an arc of 62, so we're going to first mark up our diagram. Then it looks like the 42 traces out to an arc of 84. So it looks like we're only missing one arc. The whole thing has to add up to 360. So that missing arc is 102. So x is 102. Then we're looking for the measure of angle 1. But the 62 here collapses down to the 1. So measure of 1 is half of 62. And measure of angle 2 is the 102 that collapses. That 102 collapses to angle 2, so that's 51. In this problem, the central angle is 106, so if I mark that as the measure of the arc, then that 106 collapses to both the 1 and the 2. So 1 and 2 are both inscribed angles of the arc, of the intercepted arc 106, so they're both 53. In this problem, the key is that these are both radii, equal radii, which make it the isosceles triangle. The base angle's got to be 70. So since that base angle is 70, then in your triangle, the missing angle 1 has got to be 40. So since that's 40, then it measures to this 40 here, and it collapses. The inscribed angle of that 40 is 20. So measure of angle 1 is 40, measure of angle 2 is 20. In this problem, marking up the diagram, it looks like the measure of arc is 66 because that's the central angle, but that 66 matches with the inscribed angle here of 33. So x is 66 and measure of angle 1 is 33. In this problem, we have a chord in a tangent. So the angle by the chord in the tangent is half the 136. So that's 68. So this angle there is 68. And then the measure of angle 2 is the supplement. So 180 minus 68 is 112. In this problem, here's our chord and our tangent. So the measure of angle 1 is 44. Okay, so then the other missing section has to be 136, but that 136 is the same as the arc that goes from here to here. So that whole arc is 136 times 2, which is 272. Is that entire arc. So if we take the 272 minus the 156, we're left with this missing section here, which is 116. And the key is that 116 arc, this 116 arc, is the intercepted arc of the inscribed angle. So half of 116 is 58. So measure of angle 2 is 58. Measure of angle 1 is 44. In this problem, here is our diameter. So the missing section is 110. And that's because the whole semicircle is 180. So if that whole section is 180, then that collapses to that right angle right there of 90. But as I'm looking at it, one thing that makes more sense is that 110 collapses to angle 1, so that angle 1 is 55. But then since it's isosceles, the other angle has to be 55 too. So both of those angles are 55. Figuring out this one, okay, so if we first find these vertical angles here, so that's the average of the two arcs. So it looks like the arc is 140 and 65, so averaging those out, 140 plus 65 divided by 2. So when we do that, we get 102.5. So that's 102.5. So angle 1 is the supplement of that. So 180 minus 102.5 is 77.5. For this problem, it looks like we could get angle 1 as the average of 114 and 125. So averaging out those, 125 plus 114 divided by 2. When we do that calculation, we'll get 119.5. Then it looks like angle 2 would be this arc of 125 and the inscribed angle within that. So 125 divided by 2 is 62.5. So that angle there is 62.5, and you have both your angles. For this problem, we have that arc is 114 and 38. So angle 1 will be the difference between them. So 114 minus 38 divided by 2. When we do that calculation, we get angle 1 is 38. There's actually no angle 2 in the diagram, so that's our answer. In this problem we have a 180-degree diameter right there, and we have 68 and 92, so it looks like the missing arc has to be 20 in order for those three measurements to add up to 180. So knowing that that's 20, now we could find measure of angle 1 as 68 minus 20 divided by 2. So doing that calculation, we'll get that the measure of angle 1 is 24. So this angle is 24, and the arc x is 20. Thank you for watching.